Hello everyone, welcome back to the Avalon game project. Last time we have implemented the DynamoDB repository, and this time we are going to implement the WebSocket, or let's call it API WebSocket Comm service. So this implements the Comm service interface. As we mentioned, we just want. So let's first take a look. Cool, two very simple method. So for the implementation is actually simple enough. We just need to so we need a couple of things. So first, so before I even start, I think we need to clarify something. So because this is a WebSocket service, we do need to find the so-called connection ID of a of the player. But the thing is, each way of communication, we might need a different unique identifier for that particular to basically track the player. Let me rephrase. So here we're using WebSocket. So what if we want to use, say for example, text message, or or we even have like multiple ways of communicating about the events. Say for example, if in the future we want to expand this so that players could receive all these events via text message, email, or WhatsApp, say for example. Like if there are multiple ways, so first of all, we don't know what ways we are going to communicate about the events to the players. That means the core game logic should not consider this. So that also means that means we should keep the player as is. Only we are going to have to maintain a map of player ID and whatever unique identifier we need, and figure out a way to maintain it. And the way we're going to do it here is to use DynamoDB. Basically it means that I think I will insert a record to the DynamoDB once a player is joined. I'm going to have, using WebSocket, all we need to maintain is all we need is a connection ID. So it will be a very simple map of player ID and connection ID. Okay, so let's do this. So we need a repository. Here I'm going to, I'll just use DynamoDB repository because yeah, we like here. So here the thing is, so we could just use the repository interface, but the thing is, um, again, repository should not care about the actual implementation of the database. So here we actually care because we are actually inserting something there. So if the repository, if the database say switches from DynamoDB to say MySQL, then like we okay. So WebSocket service doesn't necessarily need to know about that, but we definitely need a different implementation of how are we going to maintain this. So this is I mean, here it's a little bit blur, but I think um, let's just keep it there because the interface we need definitely does not exist in the repository original repository interface. And we will be needing a endpoint. Actually, so we need these. So for notification, this is so actually the gateway management API. We have the client. So let's first implement notify. So this will be very simple. Actually, so we will be adding this there. Get a connection ID. Okay, so what the data it looks for is actually why it doesn't like this. Just that sticked. Okay. So this is oh. So apparently data class has this method. I didn't know about that. Yeah. Oh, actually. So so if successful, we might want to log something. Yeah, let's okay. So let's log it out. Okay, so in this case, we will know who is notified, and if there's an exception, log dot error fields info. Yeah. Okay, so okay, so this is pretty much it. The next thing is to broadcast. Broadcast is a little bit tedious because first we need to get all the connection IDs. Do we need a game ID though? Let me think. So if we need a game ID, we could. Yeah, we need a game ID. So if we have the player ID, I think we still would need. So event, we have game ID in the event. So I think the primary key I still wanted to be game ID because in this case we have identifier of all the game events in the same place. So okay, let me do it this way. So here we're adding a game ID, it's a string, and coming back here we are also using a event.game ID. So let's add it there. This is a string. It's a list of string. Okay, so the return value, of course, is a list of string, but here it's just a string. Perfect. So the next thing is yeah, I'm just um, so here so here I think I'm going. So here I think this is the only place where we need uh, asynchronous invocation, aka threading. The thing is, like calling. So here, what we're doing is basically here what we are basically doing uh, a uh, a service call to the API gateway, and the making a service call. It's basically I/O input output, and it is time consuming while not computation heavy. And it is definitely a best practice to parallelize these method calls because we definitely do not. So we're calling this say maybe 10 times, and these like this is a broadcast. We want these events to be sent to everybody. We don't have to wait until the first one finishes to start the second call. We could just make 10 calls at the same time and just be done with it. So, okay. Okay, let's do threading. Right. So now we have the IDs, so we just do um, hmm. Oh no. Actually, we'll have to mm, No, I think mid is much better. It's a string, and if not even the data is also a string. So we're just gonna do this, and here we would just have so this one, I think I'll deal with it in the repository. So okay, now yeah, we're duplicating, so I don't like it. Okay, so now we get the event, we get the threading, target image, argument is those, thread start, threads the append. Okay, so now we have created all those threads. So join means we want all the threads to finish. So I'm actually trying to figure out if there's any better way of doing it. Let me see. So we could potentially take advantage of okay, we could have a thread for executor. I think this is much better. I myself, I'm not a huge fan of managing threads because there's always something going wrong, and plus it's not very elegant. Like we're doing two loops, so let's see. So actually I want to have Nah, it's fine. No, I don't wanna. Okay, max workers, then okay, that's it. It's that simple. Okay. So now we have implemented the Comm service. Now we want to go back and implement the two methods we added here. So this is also actually very simple. But also, I think another thing we need to do is so first we have to put it there to actually to put there so that we could query it later. No, the connection ID actually should be so in this way we could just query using query all the connection IDs using the using a dynamo table query. Okay, so this works, and when we want to get the connection ID, all we need to do is if no item and this one of course is actually much simpler. Key condition PK begins with this is game ID, the sort key prefix is connection ID. So once we get the items, we just return the connection IDs. Perfect. No, yeah. In this case, why do we need? No, we still need. Oh. We do need player IDs. That's interesting. Okay, so apparently we can't really get that. So in this case, I think. So in this case, broadcast is just multiple notify. Oh, it's already doing that. Well, in this case, let's do this. Then we don't need, like, we have one less method to implement, which is good. So here, instead of we no longer need connection IDs, we need player IDs, and for player ID in player IDs, this is not emit, we just want to call notify, and this is just player ID. Cool. So now everything's so these can all go in parallel. Yeah, perfect. Cool. So we have these. Let's test it out. So first the DynamoDB test. Hopefully we can auto-generate them. Okay. So let's run one first to make sure everything's still passing. Very good. Okay, so let's see the auto-generated test cases. So now we have game ID, player ID, and connection ID. So DynamoDB, let's put it there. Game ID, player ID. Oh yeah, this. Yeah, we need a game ID. Player ID. Do we? Yeah. So we do need a game ID. Thank you. Game ID, player ID. Nope, the game ID isn't this. So once we put it there, we want to verify if we can get this. It only has one. And okay, this is pretty good. Let's run it. Oh, connection ID. Still, what? Assert PK SK. Oh, stupid. Okay, now it should pass. Cool. So let's test the get connection ID. Okay, so now first of all, we got all these, we put it there. Let's see if we could query that. Let's also put it there just in case, right? Perfect. Okay, we have these, and let's now run the tests for the let's add a new test for the Comm service. Is everything still passing? Perfect. New test WebSocket Comm service. Okay, so okay, now we have this. So a couple of fixtures. So we definitely need to hash, the bottle 3. Okay, so now we want to nope. This is dev WebSocket Comm service. We need photo 3. No, actually, we only need API gateway and the repository. So now. Yeah, we need an endpoint. Endpoint URL equals to HTTPS mock API gateway endpoint. Okay. Of course, this goes to endpoint URL. And let's import this lambda's WebSocket Comm service dot. Yeah, actually this is right. So the client return value return mock photo 3 and and API gateway, and this is auto use equals to true. Okay. Now, we need to. Yeah, this is a. This is another reason we wanted to use the like high-level abstraction, so that we could just mock the executor, so that we don't really have to worry about the actual management of threads. Here we only want to know, okay, this thing like this thing is there, so this thing is called in a certain way, and we are, because this is a like built-in module, so that we don't have to worry about its correctness. All we have to do is just confirm that we called it and it worked. We called it properly. So actually, yep. Now class equals to this. Then return value equals to this. The reason we want to auto use to set auto use equals to true is because here we're just initializing this. This is not a dependency injection, so we have to mock up we have to mock up the component here. Actually, you know what? Let's remove this. So all we need is to have it here. So we have a mode of 3 and we have this. So now, because this is the dependency, so before we initialize the WebSocket service, these two patch will be called, so we can be confident that this is okay. So now I want also to have a repository. So now we have everything. So no, broadcast. I almost want to say I want to test notify. So we need a WebSocket service, repository, and API gateway. Do we need a marker event? No, I think I want a real event because we're event game ID. Actually, so the event we are using here, it has ID, it has game ID, we have type is an event type, player join is pretty good. Event type, we don't have player join. Oh right, we changed it. Player joined. Now we have recipients. Something's not right. We don't have this. God, it never has this. So we have to get player IDs ourselves. Okay. It always has player ID, which is good. But so event. No, actually still no. Yeah, I think we still need to get connection IDs. So, okay. So once we have the connection IDs, We will have it actually we no longer need this. So we get connection IDs. Yep, let's implement this. So connection ID, game ID, perfect. This is right. So we have test dynamic B. Let me finish this up. So let's see connection items. We have these items, actual connection IDs equals connection IDs. Now, so I don't really care about the orders, so I'm gonna change it to a set. Let's see if it works. It works. Okay, so let's go back to the WebSocket service. So now we have the connection IDs. We have to change it again. Connection ID. Now this is not notify but still emit. Connection. Yeah. Okay. So now let's go back and test it out. Recipients, key value. What else? Hey. No. Comm service. So event payload and timestamp. Okay, so now player ID equals to player ID. The get connection ID, we have the connection ID. So given when we do this, then we want to verify that we get connection ID got called by these. We want to verify that the post item equals to data. I want to use this JSON.dump s JSON as dict. Yep, cool. Let's run it. Even what? Object. Is not why? Why is it not serializable? Fine. ID, game ID, type. actually, I just want to use this. So let's see. Still. So in this case, we could just use this. Okay. So we don't need as dict, which is pretty good. Okay, let's see. Where? Okay, fine. I'll just implement this. There it goes. Yep. Okay. Perfect. So now we want to test the a little bit more complicated. Okay, we have the thread block executor, do player join timestamp, same thing. Connection IDs, we have the two broadcast. We want to make sure that the repository get we called by this. And the executor submit, assert any call, connection ID 1, 2, emit, and wait equals true. Yeah. Okay, how about now? Perfect. Okay, so this is pretty much done. So today I think I'm just gonna pause here. We made some pretty good progress. We have implemented the WebSocket Comm service, added a couple of new method to the DynamoDB repository needed for maintaining the connection. So next time I think I'll start to actually implement the two missing services from game service and player service. Yeah, so I'm gonna wrap up here. Thank you everyone for watching. See you next time. Bye.